Intermediate Algebra for Statistics, Finding Linear Models. Lesson objective: find the equation of a linear model by using data described in words. Lesson objective: Example 1. The number of Chrysler employees have decreased approximately linear from 63,000 in 2002 to 45,000 employees in 2007. Let N be the number of Chrysler employees, measured in the thousands, at T years since 2000. Number 1, find the equation of the linear model. Number 2, what is the slope? Explain what the slope means in words. Number 3, what is the n-intercept? What does it mean in this situation? Solution: the variable t is the independent variable and n is the dependent variable. As an OR pair, we have t, n. From the problem, we have 2 points, 2 and 63, and the second point, 7 and 45. We first want to find the slope between these 2 points. The slope's the difference of the y's over the difference of the x's, and we end up with a negative 18 over 5, which becomes a negative 3.6. Now we use a point and the slope to find the equation of the line. The point I will use is 263. So if you recall y equals mx plus b, we know the slope is a negative 3.6. Using the point 263, we have 63 equals negative 3.6 times 2 equals b. Now we multiply. To solve for b, we add 7.2 to both sides of the equation, and we have b is equal to 70.2. So the equation would be y equals negative 3.6x plus 70.2. Let's rewrite this equation using the variables from our problem. So the equation becomes n equals negative 3.6t plus 70.2. To verify the equation, we can graph it on the graphing calculator and check to see if both points are on the line. So we hit the y equals, we type in the equation. Now we hit the table function, which is second and graph. We scroll down and we see when x is 2, y is 63, so that point is on the graph. And we scroll down when x is 7, we see that y is 45. So that's our second point. So we have verified that both points are on the graph. To graph the equation, we press graph, but there's nothing in the viewing window. So if we press the window button, which is next to the y equals, we see this. This is the default window setting. X min on the x-axis is negative 10. The max on the x-axis is 10. It's counting by 1. The y-min is negative 10 to a positive 10 for the max, and it's counting by 1. So we cannot see this graph in this viewing window, so we need to change it. Now if you recall, we're given the points 263 and 745. So looking at the x-axis, these 2 points span from 2 to 7. So if I go back to my table and I scroll until I start seeing negative numbers for the y, that will sort of help me define what x's to use. Because in the terms of this problem, negative numbers do not make sense. As far as the y values for the window setting, we are given 45, 63, and the y-intercept is 70. It'll probably be a good idea to let the maximum y be a little bit larger than this, and then let the minimum be a little bit less than 0 so we can see the axis. So these are the values I choose. So my x-min is negative 2 because I want to see the y-axis, and it's going up to 20 because at 20 we are in negative numbers, and I'm counting by 2. For the y-min, again, I want to see the x-axis, so I'm going to pick a number a little bit less than 0, and again, I want it to be larger than my y-intercept. And since this spans 85, I'm going to count by 5. I hit graph, and I can see both the y-intercept and the x-intercept. So whenever you're graphing a linear function, you always like to see both intercepts if possible. The slope is a negative 3.6, or we can say it's a negative 3.6 over 1. This will help us with our interpretation of the slope. As the x increases by a positive 1, the y is going to decrease by 3.6 y units. So in the terms of this problem, we would say, according to the model, as the years since 2000 increases by 1 year, this is the change in x, the number of employees that work at Chrysler decreases by 3.6 thousand. So this is the change in y. Be sure to include your units. Number 3, the n-intercept is 70.2. Now what does that mean in the terms of this problem? Well, if you recall, the y-intercept is the value of y when x is 0. So for this problem, we would say the model estimates that there were 70.2 thousand Chrysler employees when our t-value is 0, and that is in the year 2000. Example 2. A business purchased a car in 2008 for $35,950. For tax purposes, the value of the car in 2012 was $20,550. A. If the business is using straight line depreciation, write the equation of the line that gives the value of the car based upon the age of the car in years. B. Graph the model. C. What is the slope of the equation? Interpret the slope in the terms of the problem. D. What is the vertical intercept of the equation? What does it mean in regards to the value of the car? E. What is the horizontal intercept of this equation? What does it represent in regards to the value of the car? And F. State the domain and the corresponding range for this problem. Solution? We're going to let t be the number of years since 2008. The independent variable then is going to be t, which is measured in years, and the dependent variable we're going to call v, and that's the value of the car measured in dollars. From the problem, we are given 2 points, 0, 35,950 and 4, 20,550. So we need to find the equation of the line that contains these points. So we use our slope formula. 20,550 minus 35,950 is the change in y. The change in x is 4 minus 0. This yields negative 15,400 over 4, which is a negative 3,850. So the equation of the line, if we write it in y equals mx plus b form, we have the slope, negative 3850, and we also have the y-intercept here, which is 35,950. Writing the equation in terms of our variables for the problem, we have v equals negative 3850 times t plus 35,950. Next, B, we want to graph it. So we type in the equation in our y equals editor. We hit graph, and the graph looks like a vertical line here, which is not correct. So if we hit our window, this is the default. So we go to our table function, we look at the values of x and we look at the values of y. My x min is going to be negative 1 because I want something a little bit less than 0 so I can see the axis. My x max is 10 because at 10 I start getting negative y values, which does not make sense in the terms of the problem, and this is counting by 1. My y min is negative 2,000, and the reason why I picked negative 2,000 is because I want to go a little bit below 0, because here I'm counting by 2,000. My y max is a little bit more than my y-intercept. So I can see the y-intercept on my graph. I hit graph, and again we can see the y-intercept, we can see the x-intercept. If I use the table, the y-intercept is 35,950, and if I keep scrolling down, I can see when x is 10, we start having negative y values, and the value of the car can't be negative. So part C, the slope is a negative 3,850 over 1. So interpret this slope, we would say, according to the model, as the years since 2008 increase by 1 year, the value of the car decreases by $3,850. D, the v-intercept is 35,950. In the terms of this problem, this means the value of the car is $35,950 in the year 2008, and that's when t is equal to 0. Next, we want to find the t-intercept, so we let y be 0 when we solve for t. So our equation is v equals negative 3,850 times t plus 35,950. We let v be 0, solve for t. So our first step is to subtract 35,950 from both sides. This is what we're left with. To isolate t, we have to divide by a negative 3,850, and we get t is close to 9.3. So in the terms of this problem, we would say the model predicts that when the number of years since 2008 is about 9.3 years, and that's in the year 2017.3, the value of the car is 0. Lastly, if you recall, the domain is the x values, and in this case the possible t values for this model, and the range is the possible y values or v values for this problem. So if we look at our graph, our domain are these values. So that would be from 0 to about 9.3. Then our range is the y values, what the car is worth, and the smallest that can be is 0, and that's going to go up to the y-intercept, which is 35,950. So this is one way of writing our domain, and this is our corresponding range. Thanks for watching.